So I have the integral from 0 to 1, integral from y over 2 to 1/2 of e to the negative x squared dx dy. The problem with this one is e to the negative x squared cannot be integrated. So our strategy here again is going to be to switch the order. So this time my west boundary is going to be x equals y over 2, and my east boundary is going to be x equals 1/2. So let's take a look at that to see what's going to happen as we try to switch these. So again, my west boundary is x equals y over 2. And my east boundary is x equals 1/2. Now, what did y range from? What did we have? Y range from 0 to 1. Okay. So what does that give us then? If y ranges from 0 to 1, that focuses us from the west boundary to the east boundary. 0 to 1 puts us right here. And there's our region of interest. So can we change it from west to east to north to south? What will that be? Looking at this, our southern boundary is now y equals 0, and our northern boundary is that line. So let's consider that. So here's our region, and we want to switch it from west to east to north to south. So I'm starting here at y equals 0, and then what will the northern boundary be? If I get up there, that would be y equals 2x. So y would start at 0 and y would end at 2x. Now, once we're there, then what does x range from? What's the lowest x value I see anywhere? What's the greatest x value I see anywhere? Lowest x value is 0. Largest x value I see is 1/2. And then what does that give me? Then I have to rewrite this in the dy dx form instead of the dx dy form. And I have e to the negative x squared in here. And this now can indeed be integrated. So let's quickly do that. So here's my inner integral that is perceived as a constant. So the antiderivative would be y e to the negative x squared as y ranges from 0 to 2x, which will give me 2x e to the negative x squared is my inner integral, which brings me here to our integral. And then this can be done with the u substitution. So we'll say u is negative x squared. Du dx is negative 2x. Du divided by negative 2x equals dx. That'll be important. If x equals 0, u equals 0. If x equals 1/2, u equals negative 1/2 squared, which is negative 1/4. So let's go ahead and make that substitution. That brings us here. So you'll notice that the 2x and the negative 2x will divide out. So I get that integral is the negative as u goes from 0 to 1/4 of e to the u du. Let's just go ahead and switch the order and change the sign. That'll be from negative 1/4 to 0 of e to the u du. The antiderivative of e to the u is e to the u, evaluated from negative 1/4 to 0, which is e to the 0 minus e to the negative 1/4, which is 1 minus 1 over e to the 1/4. So again, the thing to recognize is the original version, we had an integral we couldn't do, but by switching the order, it turned into a relatively trivial problem. Let's go ahead and do one more. So this is an integral of 1 over natural log y dy dx. I have no idea how to integrate 1 over natural log y, so I'm hoping that maybe I can switch the order and get an integral that I can do. So let's try that. So y is on the inside. So this means y ranges from e to the x. That's the southern border. Y equals 10 is the northern border. and x ranges from 0 to log 10. So let's look at that graphically. So our southern border is y equals e to the x. Our northern border is 10. X ranged from 0 to log 10. So where will that be? Here's our region. So if I want to change this, I have to think about what is my west boundary, what is my east boundary, and it will be probably important to figure out what this point is. So that point is natural log 10 and 10. And this point down here is 0, 1. Of course, this point is 0, 10. So let's keep all that in mind, and let's reanalyze this in the dx dy direction. So this is our region, and we said going south to north didn't work. So let's go west to east. If we start here on our y-axis, that is the line x equals 0. Then what is this? That boundary was y equals e to the x, but I need to write that as a function of x. So we take the natural log of both sides. Natural log of y equals x, or that eastern boundary is going to be x equals natural log y. So looking at this then on the inside from the west boundary, x goes to 0 to natural log y. Now, what does y range from? What's the lowest y value I see anywhere? What is the highest y value I see anywhere? Lowest y value I see is 1, and the highest y value I see anywhere is 10. And then we're going to integrate this 1 over log y. And then our order changes. X is on the inside. It's going to go to dx dy. So let's look first at the inner integral. X is the variable, so 1 over log y is perceived as a constant. So it's 1 over log y times the integral as x goes from 0 to log y of 1 dx. The antiderivative of that is just x. 1 over log y x from 0 to log y, which is going to give me 1 over log y times log y minus 0. After all is said and done, the inner integral is just 1. So the outer integral is the integral as y goes from 1 to 10 of 1 dy, which antiderivative is y from 1 to 10. 10 minus 1 equals 9.